So the zero product property. The word product implies what mathematical operation? Multiplication. So we're talking about things that are multiplying, okay, to get an answer of 0. So I'm going to use some letters right now, and I'm going to say, suppose you had A times B, and it equaled 0. Tell me what you know about A or B. One of them has to be 0, right? Everybody's probably thinking that in their head. So would you be okay with me saying if A times B equals 0, A equals 0, and or B equals 0? Because would it work if they were both 0? 0 times 0? Yeah, that would equal 0. Would it work if A was 0 but B was 5? Yeah, 0 times 5 is 0. And would it work if A was 3 and B was 0? Yeah, if you multiply and there's a 0 in your multiplication, then the whole thing equals 0, right? Okay, so do you remember in geometry, you spend a lot of times with like theorems and properties and postulates and axioms. I mean, all I have to do to this is put in an if and a then. If A times B is equal to 0, then A equals 0 and or B equals 0. Right? And this one we could really make biconditional, like with an if and only if in the middle. We could switch it around. If A equals 0 and or B equals 0, then A times B is 0. So this is like the base, the foundation for solve by factoring. Okay. Because I'm actually going to do the one that we asked about in our homework. Morgan asked about x squared plus 3x plus 2, which was a solve by graphing. But we saw, decimals. We're not actually plotting that point. So how do we know for sure those are the real points? Well, this is one we could have solved by factoring. Okay, I always ask myself this when factoring a trinomial with a coefficient of 1. See if this rings a bell for factoring, because that's going to be the hardest part of today. What are factors of 2 that add to make 3? 1 and 2. So those are my two factors, right? X plus 1 and x plus 2. To factor something is like to unfoil it, to bring in the parentheses. Okay. And I just use that method like that's a little pattern that I know as long as the leading coefficient is equal to 1. And you can always like double check, like x times x is x squared, and then I check my outside is 2x and my inside is 1x, so isn't that 3x? And then the last term's 1 times 2 is 2, so I wrote the right factors. Okay. Well, if we write it like this in its factored form, they're called factors because they're getting multiplied together. So now I can employ the zero product property. This factor, x plus 1, is A. This factor, x plus 2, is B. If they're multiplying together to be 0, either x plus 1 is equal to 0 or x plus 2 is equal to 0. So set your factors equal to 0. And can you solve for x? X is -1 and x is -2. Same answers we got in the graph? Yep. These are going to show up as x-intercepts. Okay, so you have the x-intercept at -1, 0, and -2, 0. Since intercepts are points, we would normally write them as ordered pairs, just FYI. But in the work that we're doing in this chapter, you're probably going to be saying like x equals, because like your goal is to solve for x, to find the missing x. So if you want to write down like, okay, what are you doing? Okay, in the first step you factor. In the second step you set factors equal to 0. And then you solve for x. So you have 3 steps to solve by factoring. Factor, set your factor equal to 0, solve. Okay. How many people, raise of hands, feel like, yes, I have done this in Algebra 1? Okay, so like I said before, the hardest part about today is can you factor? Okay. So, I love factoring. Woo! Factoring. Okay, so I have 5 statements up here, and I don't even have equations. Right now I'm not like solving it. I just want to know like where are we on factoring? Let's talk about different ways to factor. So I'm going to let you kind of play around with it with you and your groups for a little bit. So see if anyone in your group has a method for factoring. If they recall how to factor, describe your process if you think you're factoring. Some teachers have like specific methods they use, and then others maybe not. We're all coming from different places, so it'll be interesting to see if we have different ways to factor, but we get the same answer. Okay, so I'll give you a few minutes. Kind of work through as many of those as you can so we can talk about them. Go for it.
Okay, seriously, the one thing I do.
Yeah, that's how I got
To get -5.
because they have to multiply -14.
Yeah, I know that. It's just that one part that really gets me. -3 too. That's always the part that I don't know.
So it's like that doesn't have an X.
I still don't know.
Have to like
You're adding them.
oh it's -5 and 5 because they add together to get 0.
Yeah.
Oh.
So if it's
Oh yeah.
wait,
And then
oh.
number 4 has one.
How?
Because the whole thing is multiplied by 2.
So it's, you just divide this by 2 and then
Oh,
oh, but then how did you get 5?
It doesn't matter.
Yeah.
So 7 over 3, 3 sevens. 7 over 3. 7 over 3.
And then add all that.
Oh,
7 over 3. Yeah, that one's a 50.
They add up to the things.
Oh, well, this is like
Mr. Stark. I don't feel so close.
Mr. Chase.
Okay, and then I'm going to be very curious from you is to use the X method for scrap.
I think it's 8 times 4.
I don't know.
So -6, have you
seen that before? Or you just put that? That's fine.
That's really true.
And you guys, do you have a method for factoring? Okay. You got a method for factoring? Or
No.
just factoring?
No, it's just,
Yeah,
except for
they
the
kind
last
of
one.
just did it. I'm sitting here thinking how they did it.
Well, talk to each other.
Yeah, I hate factoring.
Well, that's not helpful, Chase.
I know. I don't like it.
You don't hate or just don't like it and X minus.
It's the same thing. Just I don't like it with burning passion.
Okay, I'm gonna call us together. Okay.
You know what, Emma?
And before everything gets out of hand, I'll call us together and bring us back. And we're going to talk about ways to factor. Okay, so if you're in a group and you feel like, wow, my group really is like factoring professionals and I'm like factoring amateur over here, then pay attention, write stuff down, listen, ask questions. If you've got other input for us about factoring, things that teachers told you in the past, let us know. Okay. I drew 2 pictures over here on the sideboard. There's something called a box method.
Oh no, I don't like it.
If you feel like you know the box method and then you're like all of a sudden factoring is coming back to you in a box and you love it, if you know that, then use it. Listen. If you know it, use it. If you know you love it but you can't remember it, go to YouTube, Google YouTube box method factoring, and watch as many videos as you want. There's going to be like a ton of them, okay? So if you have that method and you feel like that's the method for you, look it up on YouTube. Miss Cronky doesn't know how to do box method. And there's also the X method, which Lexi was using the X method. So you can use the X method, Lexi, for the first one, right? Okay, so you do what? You put C on top. So she puts C up here, so that would be negative 14. Then you put B in the bottom of the X, so do you put negative 5X? Or just negative 5? And then,
So the numbers that you use on the side of the X have to add to -5.
okay, so they got to add to BB, and they got to multiply to BC. So, I mean, like, what factors are we choosing? 7 and 2. And it should be a negative 7 and a positive 2, right? Because you have to have opposite signs so that it makes negative 14. But then your number has to come out to be negative, so the bigger number has to be negative. Negative 7. If you did 7 and negative 2, it would be positive 5 in the middle, right? Okay. Now, if you have seen that X method before and like all of a sudden you're like, yes, I love the X method, then, you know, YouTube, Google, whatever, find the method that works for you. To me, the X method is something, you know, like that's kind of what I'm doing in my head when I go to the back of the trinomial and I say, what are factors of 14, negative 14 that add to make negative 5? Well, I would say negative 7 and 2, right? But I don't necessarily always write it down in the X. Okay, the method that I use for that, I'm going to call simply, guess and check. So when I walked around to a lot of pods, I'm like, do you have a method? And people are like, no, I'm just doing it. Okay, I'm just seeing what works, right? The most important part of guess and check is what? Check. Okay, so like, obviously you can guess any number values that you want in the 2 binomials, but it is your responsibility to check that they actually work. Now, as long as the leading coefficient is a 1, you can use my shortcut where you do factors of the constant factors of the constant and figure out what adds or subtracts to make your middle term. Okay. So if I were to check this, I can do it 2 ways. I can write it down, like FOIL it out. What would it be? x squared, outside terms, plus 2x, inside terms, minus 7x, negative 7 times 2, minus 14. And can you see that that is going to be the same trinomial? Yes, it is going to be negative 5x. Can you imagine that I would have some algebra students who put the signs in the wrong place, and then they don't check their work, and they get all their answers wrong, and they're super frustrated because they feel like they can't do math, but they're just not being careful? Okay? So I like guess and check. The reason why I like it is that if you don't remember the box method or the X method, then you can't do it. You're like, I can't do it, I can't remember. But if it's just guessing, then you're like, okay, I can guess some numbers. I can put some random numbers in. Okay, what did you guys do for x squared minus 25? Morgan?
Just when you don't have a b value, so you don't have to really you just have the 2 to work with, so you just do x. But since it's a negative, you can't just do 5 squared, so you have to do positive and negative 5.
Yeah, I mean, you don't have an x term. What is the coefficient to x then? 0. So it's like, what are factors of negative 25 that add to make 0? 5 and negative 5, because it has to be opposite signs. So I love that. That's also a special factor pattern called difference of perfect squares. So if it's like x squared minus 16, it's x plus 4x minus 4. If it's x squared minus 144, it's x plus 12x minus 12. Just the square roots of the first and the last with a plus and a minus. Okay, was any group able to factor x squared minus 6x? Tommy, what'd your group get?
I got x minus 6 and x minus 0.
Okay, so maybe like this would be a good one for us to check. So I'm going to FOIL this out. First terms give me x squared. Last terms give me minus 0x. Inside terms give me minus 6x. And then last terms, negative 6 times negative 0 is a plus 0. Is that going to be x squared minus 6x? Yeah, because these things are just zeros. Okay. Did anybody factor it differently? Could you simplify one of your factors? X minus 0 is just x. Okay. So I would say if I were factoring this one, it's not a full trinomial. Both terms have x, so the only thing they have in common is x. I can take an x out of both terms, and I'm left with x minus 6. Like, divide x squared by x, I get x. Negative 6x divided by x is negative 6. That's called factoring out a common monomial, one term, or a greatest common factor. Okay, what did you guys do for 2x squared minus 12x plus 16?
Well, they all have a factor of 2, so you can put 2 on the outside.
Excellent. It's just like what I did with the x squared minus 6x. If you notice they have a common factor, take it out. What's the benefit of taking out the 2 right away? All your numbers get smaller. It's much easier now, especially because I have this leading coefficient of 1, to ask myself what are factors of 8 that add to make negative 6? Negative 4 and negative 2. So then I can factor it again. It's x minus 4, x minus 2. Now, if you didn't take out the 2 first, you could have still factored it. Okay. You might have tried factoring it more like I'm going to factor the bottom one, which is really where guess and check is really important. But I always check for common monomials first. So if you want to make a little note in your notebook, check for greatest common factor. If you can take something out of all the terms, take it out in the beginning. It makes it so much easier. Okay, so this last one, do they share a common factor, 3, 7, and 10? No. You cannot use the old pattern where you say what are factors of negative 10 that add to make negative 7, because you have this leading coefficient of 3 out here. And even if you think about that, if the factor is negative 10, the factors of 10 never have different signs, so they're subtracting. They never subtract to make 7. 5 and 2 would be 3 or -3. 1 and 10 would be 9 or -9. 5 and 2 will add to make 7, but it won't subtract because this is opposite signs. So this is where guess and check is super important. Okay, it's a trinomial, so it should factor, if it does factor, as two binomials. Okay, when I start my guess and check, I look at the first term. Try to stay awake because this is factoring and it's really important for the rest of the year. What could multiply together to give you 3x squared? 3x and an x. Okay, so there I'm guessing it's 3x and x. This is nice because that's prime, so there's not a lot of options. Okay, then skip your middle term and go to your last term. What could multiply together to give you 10? 1 and 10 or 2 and 5. Now here's where guess comes into play. You may not know which one it is. Okay. As you do more guess and check, you get better at kind of like ruling some out. I'm going to model some of my guess and checks, so I'm going to do it wrong for a little bit. Let's say I put in a 2 and a 5. Before I cement those as my answers, let me check my outside and my inside terms. So see my fingers? Outside, inside. What's your outside term? 15x. What's your inside term? 2x. Will 15 and 2 ever make 7? No. Okay. So it's not the 5 and the 2 right there. Let's see if I can get this smaller. No. How do I get that photo? Okay, so it's not the 5 and the 2. What if I swap them around? So I did a 5 and a 2. Outside term? Inside term? Will they make -7? No. 6, oh darn it. 6 and 5 will make 1 or -1. Okay, so it's definitely not 2 and 5. If it factors, it's got to be 1 and 10. Can you look at it right now and decide where your 1 and your 10 should go?
10 probably on the left and 1 on the right.
10 on the left, 1 on the right. Then we get 3x and 10x. Will they make -7x? As long as which number is negative? The 10, the bigger number. So it's got to be -10 and +1. And then think about that. Of course, that gives me my -10x plus 3x gives me my middle term. My first term's checked out to be 3x squared, and now I have -10 times +1. Wouldn't that be -10 my last term? So I've checked it. If you need to, you should FOIL this out. If you have to write it down, then write it down. It should literally take you like 10 seconds at most to write down. Okay. Okay, so that's its factored form. Those are harder to do when the A value is not 1. Then you've really got to kind of run through guess and check.
So our answers,
Well, this is factored.
right?
This would be your answer in factored form. Okay, so this is factored. Now, what if I say solve by factoring? So what if I make that equal to 0? And then this equals 0. What do you have to do with your factors? Set them equal to 0. So 3x minus 10 equals 0. That's 3x equals 10, or x equals 10/3. Okay, and then x plus 1 equals 0, so x equals -1. So your solutions are -1 and 10/3. Okay, and we could go back up to all of our factoring examples and do that if we wanted to solve by factoring. But I expect you to be really good at the solve part. Just set your factors equal to 0. It's the can you actually factor it. Okay. Now, if you are really struggling with factoring, please go online and look at some videos, okay? Or come in and see me for help, okay? I think it must be, are we close to 12:32 or at 12:32? Oh, we have 2 minutes. Okay.